Hi, it's Callahan Tutors here today, and I'll be discussing how to find the excess reactant. Just a heads up, this problem we will be using the information that we found in the prior video, so if you haven't watched that, I suggest you do. Anyways, we will be using the mass of the products we found in the last video to calculate the mass of each excess reactant. To refresh you or inform new viewers, the reaction we are discussing produced 16.1 grams of water and 18.4 grams of acetyl. The first step to find the mass of the excess reactants is to find the mass of each excess reactant in the products. This is because we need to know how much of the reactants was used up in the reaction. You may be asking yourself, how do I find the mass of specific elements in a compound when all I am given is the mass of the compound? Well, here is where an important concept comes into play. Percent composition. As displayed here, percent composition is used to find the mass of an element in a specific compound. Note that by mass of the element in the compound is referring to the mass shown by the atomic symbol in the compound. So, in something like HO, there is a mass of 16 grams of oxygen in the compound. When we are finding the percent compositions of the ERs in the products, we can simplify this process by not calculating the mass of carbon in the products. This is because carbon is not an excess reactant, since all of it is used up in the reaction. Alright, let's move on to actually doing the calculations. As shown in the prior formula, since there are two hydrogen atoms in water, there is hydrogen's atomic mass multiplied by 2 in the numerator. As for the denominator, we have the atomic mass of the compound, water. Then, we are multiplying this fraction by the actual, what was produced in the reaction, mass of water. From this, we get that there are 2.03 grams of hydrogen in the water. Using the same process, we find there is about 16 grams of oxygen in the water as well. Next, we can repeat this process for acetyl. Basically, you can imagine this process as a plug and chug. This is because the placement of the variables is the same every time. Using this formula, it is found that the acetyl produced contains 1.4 grams of hydrogen and 6.3 grams of nitrogen. The second step in the process is to add the masses of the excess reactants together. This means to add the mass of the same excess elements to each other. As a result of this, it is found that in the compounds produced, there is 3.43 grams of hydrogen, 6 grams of oxygen, and 6.3 grams of nitrogen. Our third step is to find the mass of the excess reactants in the reactants. We can do this the same way we did for the products. Yes, percent composition really is this easy. For carbon monoxide, there is 14.3 grams of oxygen within it. For ammonia, it has 7.09 grams of nitrogen and 1.5 grams of hydrogen. Finally, it is simply stated that there is 10 grams of hydrogen, so no work is needed here. The final part of our work is to subtract the mass of the excess reactants in the products from the mass of the excess reactants in the reactants. By doing this, we will find how much of each excess reactant is left over. We will do this by adding together the mass of each excess reactant of some of the elements in the products and subtracting the element of the product excess reactant from that. By doing this, we get these results. With all that done, thank you so much for watching. I was wrong. I will not be able to upload on a weekly basis, but I will upload consistently. Thank you so much for supporting me, and I hope you have a great day. Bye.